Okay, students, let's discuss the next question, that is salient feature and limitation of Kennedy's theory. What happened? Previously, a long investigation was getting done over a channel of Upper Buri Doab canal system, which is located in Punjab, Pakistan. Then, later, what happened? R.G. Kennedy has arrived into the theory which state that flowing water in a channel has to counteract some amount of friction against the bed of a canal. But natural, it is that when a water is flowing over a bed, it is definitely going to create some friction. The water is definitely going to create some friction with the bed. So this friction is going to cause or going to give rise to the vertical eddies and eddy current, which are responsible for keeping the silt in suspension. Obviously, if a water is getting in contact with a bed of a channel, it is going to create a vertical current, vertical eddies, which are going to lift the silt and keep it in suspension. This suspended silt then further going to get rise toward the surface. Okay, so what are the assumptions Kennedy's has actually made are as follows. Number one, eddy current is totally dependent on the roughness of the bed, but natural, it is going to get dependent on the roughness of the bed. As the bed is lined, the current will be minimum, and if the bed is undulated, the eddy current will be more. Similarly, if the bed width is more, the silt supporting power will be more. So, silt supporting power is proportional to the bed width. Hope you have seen it. Let me revise it. Let me repeat it. What the second point says that if the bed width is more, the silt supporting power will be more. Since more the bed width, more will be the silt which is going to get lift up in suspension. So silt supporting power is completely proportional to the bed width of a stream. Third assumption was that this theory is applicable to those channels which are flowing through the bed consisting of sandy silt or similar to sandy silt or similar to those which are existing in Upper Buri Doab canal system. Okay, again, what happened? He has established the idea of critical velocity, that is called as VO, which will keep the channel prevented from silting and scoring. So he has given us this equation for critical velocity, which is VO equals to 0.55 d to the power 0.64. But then here we can see that critical velocity is dependent on the full supply depth. Critical velocity is dependent on the full supply depth of a channel. Then he realized that the critical velocity can be affected by the grade of silt. Definitely, if the grade of silt is very fine, the velocity is going to be much more. But if the silt is coarser, it is going to affect the critical velocity. So, sand which is coarser and sand which is finer are going to affect the critical velocity. So, this equation has been revised by R.G. Kennedy and has modified it as VO equals to 0.55 m d to the power 0.64. Let me repeat it once again. BO equals to 0.55 m d to the power 0.64, where m is a silt factor. This is the significance of a Kennedy's theory. Now let's come over to the limitations in Kennedy's theory. So, what has been found as a drawback in Kennedy's theory was he only considered the average regime condition. Now, what is this regime condition? Regime condition is those conditions in which there will be no scoring nor silting taking place in a channel. What happened? Kennedy has considered the average regime condition where there will be nominal scoring and a nominal silting which is going to take place. So this theory is not applicable for completely lined canal or for a completely rough canal. Second theory, that he has not considered B by D ratio and its significance. Third point, value of M is not fixed, it is arbitrarily fixed. So he has considered value of M as 1.1 to 1.2 for sand which will be coarser than standard sand, whereas M equals to 0.8 to 0.9 for a sand which is finer than a standard sand. Fourth drawback, he has not given any equation for bed slope. He has not given any equation for bed slope. Further, the theory is completely based on trial and error method, where you will have to consider the equation of V0 equals to 0.55 m d to the power 0.64 and equate it with another equation of mean velocity, which is V equals to C under root RS, and where C is a factor which is calculated by Cutter's formula. So whatever the drawback which is available in Cutter's equation, whatever the drawbacks of Cutter's equation will get automatically incorporated into Kennedy's equation, as it is dependent on Cutter's equation. So these are the limitations in Kennedy's theory. So basically, what is the Kennedy's theory? It is actually a revised part on upper berry dope canal system, which has previously been investigated by few researchers, and he has stated that the water which is flowing in a channel is going to counteract some amount of friction against the bed of channel, because of which a currents will take place which will going to lift the silt in suspension. This suspended silt will come up, will get rise up toward the surface. Okay, so he has considered that eddy currents are completely dependent on roughness of field, and the silt supporting power is completely dependent on bed width. Third, this theory is applicable only for sandy silt and for those sort of grade of silt which is available in upper berry dope canal system. Then he has done some investigation and has found out from his research a formula for critical velocity. Then after a few years, he has incorporated the silt factor M into his equation. Limitations are, he has taken average regime condition. He has not considered B by D ratio. He has given the value of M arbitrarily. He has not given any equation for bed slope. This Kennedy's theory is based on trial and error method, where he has to equate his equation with mean velocity. And lastly, since the mean velocity consists of one factor which is calculated by Cutter's equation, so whatever the errors available in Cutter's equation will get automatically incorporated into Kennedy's equation. This is it. Hope you have got my answer.